Welcome to this talk around automating secure and scalable AI deployments on Azure with the help of HashiCorp tools. So despite the immense hype and potential that artificial intelligence, machine learning, deep learning and generative AI is creating, a staggering 80% of AI projects in organizations are failing. So this report by Rand is also supported by a Gartner report that shows that 30% of all AI projects never get past the pilot stage. And so why is this? Fundamentally, a lot of the top priorities when thinking about creating an AI project are not being dealt with directly and therefore causing these failures. So what are these top priorities? So from our experience, we've seen three major challenges. The first of these is building the foundations. So looking to get started as quickly as possible and build some repeatable patterns that can be used throughout the organization and throughout the skill set of those that are looking to build these. The next is dealing with a new security challenge, and we'll dive into this in a lot more as we go through this presentation, but fundamentally you have the traditional challenge of perimeter security, you have zero trust and how do you apply that, but also you have a new security challenge with how data is being used and what will be actually represented to those using the interface. And then finally, you're looking at how do you scale this throughout your enterprise. You have a limited amount of skills, you have a large number of people who want to use this new product, and so how do you scale that throughout the organization? The trouble with these priorities are they're fundamentally infrastructure problems and not business outcome problems. And so from an executive level, a lot of the focus is around achieving a better customer experience as soon as possible or improving customer retention as quickly as possible. And so being able to achieve these and solve these problems quickly is key to being able to get to a business outcome as quickly as possible so that you can start to see that return on your investment in this new infrastructure and get the business outcomes that you are ultimately looking for from your AI deployment. So how does HashiCorp help? Well, our secret sauce is that HashiCorp has a set of tools that can fundamentally fit into solving those challenges. And so we have the ability to build tools that will help you set your foundations. We have tools that will help you with solve that new data challenge. And then we have tools that allow you to actually scale this out through the organization, particularly when we think about the fact that HashiCorp focuses on workflows and not actual just tools. These workflows allows you to integrate in with different platforms across different community groups and use the whole partner ecosystem to make a comprehensive solution for your AI deployment. So we know that cloud is really complex, and when you look at the elements that you are required to build to stand this up, obviously being able to understand and deploy this easily and repeatably needs a lot of skill. Now, where this really starts to leverage in HashiCorp and Microsoft's favor is the fact that we have jointly built a whole ecosystem around our Terraform product. Terraform being our infrastructure as code tool. This tool has been worked with Microsoft and has a joint engineering component where preconceived and pre-created or curated and verified modules have been published that can be used to then start using as building blocks to put together to get an outcome around your AI infrastructure as quickly as possible using best practices, well architected and cloud adoption framework principles so that what you are getting is not only best practice and will meet the best security standards, but are already designed using the best knowledge from those who have actually created the platform themselves. And so being able to use this repeatability gives us the advantage to get going quickly and solve that foundational challenge. The next challenge is obviously thinking about this new security paradigm. And so even though we have built our zero trust and applied our zero trust principles to our infrastructure, we have to think that there is a new security challenge when actually starting to communicate and use these chat-like interfaces. What we have to think about is that you have a chatbot that is extremely intelligent and has a vast array of information at its scope that it can use. And this is very much like allowing or having a infant in your house that can answer, who is incredibly intelligent and can answer all of the questions. However, they don't have the necessary social or even construct skills to know how to deliver the right information to the right person. And therefore, if you ask them a question, they are going to try and answer that question as succinctly and as quickly as they can. And so therefore, once you ask that question, they are going to give you an answer whether it's right or wrong. They have the permissions to do so. They have the right to be able to be there and telling you this information, but it doesn't necessarily mean that it's information that you want to get out of that. And so a way that I like to think about this is if you asked your son or daughter about some financial information that was private and confidential, they probably would actually answer them with an answer that they'd heard and repeat information that obviously you may not want to be, that was privileged and may not want to be left outside the family context. And so this is the same challenge that we face with this new security paradigm. Plus, we also are seeing things where as the architectures around AI are evolving, so things like using agents and having agent security, we're now seeing elements of traditional attack profiles being applied to these agents and these architectures. So the things such as prompt injection to actually try and expose confidential information or keys. We're seeing model poisoning, where inappropriate information is being injected into the model on purpose to try and confuse it or get inappropriate answers out of the model. We're seeing autonomous systems being used against models to try and actually get people to move and use the wrong endpoints for data sources. And we're seeing DNS spoofing, so that from an endpoint perspective, we're seeing attackers trying to start moving agents into inappropriate models to use or data sources. And therefore again, compromising the information that comes out of that query. So one of the ways that we can deal with this, particularly from an agent perspective, is getting the agent to have a authenticated access into the model. So if we leverage something like Vault can actually be used as a authentication agent, whereas our AI agent now needs to get permission to access the data and the information at the right permission level and just in time. And if anyone or anything tries to obviously set up a misdirection, they will not have the right permissions to be able to access that data, because that Vault does not give them permission to do so. One of the things we've also seen, particularly around RAG environments, is that we're seeing private data leaked. So we're seeing credentials and personal information exposed, whether that is intentionally or unintentionally through just the information being ingested into the model and therefore used unknowingly, and information being able to be retrieved from it. We're seeing this as a potential problem as well. We're seeing weak access controls, so data being either mistagged or misrepresented and given the wrong permission sets, so that again it is being used within the model in the wrong way. And we're seeing model tampering again, where data is being leaked because attackers are actually now applying misleading tags on purpose, so that they can then use that interface or that environment to be able to extract the information out of the secure zone. How we deal with this is that we can do things like using a transit engine, which can actually, as the information is ingested into the primary data source or the warehouse, we can actually use a filter and encrypt that data, looking for specific personal context. So that could be PII data, for example, or credit card or social security numbers, and actually encrypting that in a bi-directional way. So even if the information does go in and someone manages to extract it, that value is unique and that value is encrypted and is worthless to that attacker. However, if that value is of use and the person has the right permissions, they can take it back through Vault, decrypt it, and actually find out what that information is. So you're not losing the functionality or value of the data, but you are obfuscating it in a way that then makes it impossible for an attacker to misuse that. So let's dive into our demonstration. Within it, we're going to take a look at a few fundamentals, those priorities. We're going to first take a look at how we can use modules to stand up the environment, and then using Vault to secure our application information to make sure there is no information leaks by the engine. So here you can see our directory structure. You can see that all of the code has been downloaded into one set of group, and this module could be used within a repository or within a module, the Terraform module registry, as a baseline to be deployed repeatedly across your environment. All of the code is here. All of the elements that you need are incorporated in this one set of code, and so you only need to have one command, or if you're using Terraform Cloud, pressing the one button that you can actually use to deploy this. In this case, we're using our Terraform apply, and we're using an auto approve, so we don't have to actually check that button to get through, and the code will run automatically. So here you can see we are going to apply and kick this off. As we kick off this build, so all of those elements that we talked about, including the AKS module at the back, the registry, building the actual application within that environment, are all going to be deployed. And so again, get into your building that foundation quickly. You now have a repeatable set of code that you can quickly stand up and use to baseline your environments, even if others don't understand what those modules are. And here you can see our application information has been delivered and kicked out into our application directory, and we're using that construct where we've even injected Vault credentials into our code to be able to allow our application to stand up. And so here now we move into our front end. And so this is our Azure OpenAI chatbot interface. And so the first thing that we will need to do is start to give it some information to make it obviously that RAG environment. So here we're finding a file that was maliciously or unintentionally uploaded into the environment and has a whole bunch of our subscription keys. So both from our Azure platform and from a data source that we need to connect to on another platform. And so because we have these keys inputted into in that file, we also have some information about who to contact in support, so some personal information, and also some information about the numbers of employees in our organization. So things that we may or may not want to see let the organization get out. So first we're going to see if we can maliciously get those other platform keys out. So let's ask a question first to quantify that the information is there and that is valid for using. So let's ask about who we can contact on the support help desk, for example. So let's see what we can do there. And there we have our support contact. So we know that our email information is being allowed to be presented and that information isn't restricted in any way, and we're allowing that information to be given to the user. So next we're going to see if we can get our other platform keys out. Let's see if someone has configured those static platform keys and see if we can get those out. Now you can see that built into the Azure platform there is some context around understanding that this information is sensitive and that it shouldn't be allowed out. So we actually have to proactively go to try and fool it. However, when it actually trips up and gives you some context, we can now say, let's see if that information is there, and now we are proactively going after and trying to manipulate the model to get that information. So show isn't working, so maybe we need to be a little bit more aggressive around what that information is to get around our security restrictions. And so now we want it to definitely tell us, and so now it's actually given us that key, and you can see that Vault has encrypted using the Vault v1 and has given it as an encrypted string. So you see now that the information has been offered up by the model and actually retrieved and presented to that user. Once, whether they were doing that in a malicious use case or not, or whether they were just being overly persistent to try and find out, that information has actually been given out. And if that hadn't gone through and been filtered and picked up through the transit engine, that would actually now be in clear text, and that user would have access to that other platform to be able to manipulate that. And so this information is obviously just a very simple use case to show how particular criteria can be selected, picked out of your data input up to your retrieval architecture, and actually then filtered through your LangChain process and given a context to then feed that filtered information via Vault's transit engine to then be protected and secured. So with that, let's go back to the presentation. And so that was a great example of using Vault for our security challenge. When we think about our three primary use cases, we had building our foundations quickly so that we can see our ROI. This is a great way to leverage things like the Azure verified modules and any of those code modules that can be inputted into Terraform's module registry to put controls around repeatable deployment. We then leverage Vault to both allow for information to be controlled and what could be visually output using the transit engine. We also use in the back end of that to retrieve secrets securely and also to authenticate across from a PKI, allowing for our data to be accessed across any platform. So in this case, we leverage both Microsoft and another cloud platform. The final part of that was to obviously allow for enterprise scale. And when we put these elements together using the HashiCorp cloud platform, this means that all of these resources can be consumed as a SaaS platform, making it easy for users and non-technical users to be able to link and start consuming these products and deploying them for their OpenAI projects or for their AI applications, so that they can get access to that information as quickly as possible and allow them to stand up and build enterprise ready, thus getting you past that science certificate and into an actual application. So thank you for your time. I really appreciate it. If there is anything further that you want to do, please reach out to your HashiCorp rep at the booth.